I'm Chris Pollock. This is my first Linux-based robot.
Cool.
Without mostly messing around with Arduino-based stuff. So it's been quite an adventure transitioning. This robot I'm designing it for the tabletop challenge this summer. Last summer I was able to get to phase 2, but I ran into some limitations. So this year, going for it. It's basically its main brain is a BeagleBone Black, and then I have like a custom interface board that the motors connect to and encoders and everything. So this month it's on manual mode. Hopefully next month we'll have it ready to be autonomous. Yeah, certainly. It's not ready to run by itself on there, but
actually maybe put something in front of it if it's not, or make it point towards the box.
So that's basically it. Just a challenge to myself to have something autonomous next month.
What, the OS is Ubuntu?
Yeah.
What do you have for sensors?
So right now is infrared, like a photo transistor, in an infrared light, sensing the bottom of the table. There's encoders for the wheels, and then I have an ultrasonic sensor that it's not on there yet, and then an IMU right here.
And then the plastic parts are 3D printed?
3D printed. I use FreeCAD to model them out, and I have a 3D printer. The cool part is the chassis holds the motors in there with the encoders keeping it in place.
Are you using TCP or Bluetooth?
I'm sorry?
Are you using TCP or Bluetooth?
The first one.
The Wi-Fi based.
Yeah.
Sorry,
Yeah.
what was the question?
Are you using Wi-Fi? How are you communicating with the robot? Yeah, Wi-Fi. It has like a little adapter on there.
This might be a really basic question. What's the tabletop challenge?
Oh, so I don't know, Wayne, did you want to?
Oh, okay. Let's see. Usually I wait for Camp to show up, but he's running a little late tonight. Tabletop challenge is basically, we do it 3 times a year, and it's basically an opportunity for people to be encouraged to build robots. Now, a lot of clubs do contests. They have a lot of fun with the contests. We tend to be challenges. I'm a firm believer anybody who builds a working robot is a winner as far as I'm concerned. So we just basically say, can you build a robot that can live on the table and not fall off? That's level 1. Level 2, can you build a robot that can take a block, you supply the block, and knock it off the table? That's level 2. And then level 3 is harder. Can you build a robot that can find the block on the table and push it into a goal? You supply both the block and the goal. Okay. So that's our tabletop challenge, and it's a way of getting people started. We've been doing it for quite a while. I think we're starting our 11th year. Yes?
Are they supposed to be autonomous?
Yes, autonomous. Yeah. And some people do some of the interesting solutions. One person built one where there's some arms popped out, and they drove to the end of the table, and the block was pushed off. So you can have fun. Okay, so that's what tabletop challenge is. And then those meetings, we actually just encourage everybody to bring in their robots, whatever state they're in, and tell us how they're doing. Because it takes a while to build these things. So that's what the tabletop challenge is. Okay, I'll let you resume.
All right. Thanks.
Okay. Okay.
All right. So, I have been recruited to do the line maze challenge. I brought up this idea of doing a line maze challenge last month, and it was said to me, "Well, that sounds great. You're in charge. Pull it off. Go do it." So that's what I'm working on. I have a little presentation on the iPad. I don't know if it comes through on the system or not. I can just step through that if there's any questions, real quick. And then they asked me to bring in like a miniature version of the line maze, so I've got that over here. So I've got my iPad drive, one of the HDMI inputs. Is it coming through at all, or I don't see it on those screens? So there it is.
There it is.
Right. So there'll be 3 phases to the line maze challenge. I talked to Camp a little bit about how to run these things. Usually 3 levels of challenge is kind of fun. So that's what we're going to do. I was inspired to do this by a friend of mine who's, I guess, got a PhD in animal biology or something like that. He said rats are really good at doing mazes, so the inspiration is to try to do better than a rat and find the cheese at the end of the maze. So is a maze using lines is simply to build walls. You guys have done this sort of thing before, I guess, so you probably know that already. But the idea here is something like this, and this will be built with these tiles and black electrical tape. And the robot would be the rat entering somewhere near the bottom here, and then the idea is where that cheese is there, that's the exit. So you have to find that exit by following the line and just either brute force it or basically find a way to get out. There's some rules here that I kind of stole from one of the other maze competitions, but basically the idea is just follow the line, try to get your way out of the maze. The second level, phase 2 idea is to try to improve your time by learning the maze, and on the second run or third run, basically going directly to the exit and not making any bad turns and having a much quicker time to get through the maze. Then in the third phase, we'll do something extra, like make the maze a little bit harder, maybe something like that. I had some ideas for that I'll talk about in a sec. This shows the tile sections. I'll show them in a sec over here. There's 5 of them. Basically, all the turns are 90 degrees. These are 1 foot square vinyl tiles from Home Depot, I think, and black electrical tape. And then there's an exit tile that has a special shape on it. And that's the guy here. It won't have that white line on it, might be on the presentation, but. And then the cheese will be there as well. My original idea was to detect the cheese with the ultrasonic sensor on the front end of the robot, but someone said, well, that's an extra sensor. If you could detect it with the tape, as well, that would be a better way to do it, or another way to do it would be, a little more fair. So through that audience, you can detect the exit by either that black shape, that square, or the cheese itself. And then, phase 3, trying to do some crazy things like maybe having a big long loop, that'll throw you way off and add a lot of time. So if you can learn the maze and figure out how to not take that loop one way or another, that'll save you some time so that your second third runs will be faster. And then depending on how you go about doing the maze, potentially some loop like this trap over here in the upper right corner might be a fun thing to serve in there. I'm not sure if that'd actually be a trap or not, but certain types of algorithms maybe it is. Anyways, that's the idea behind it. And then the tiles are these things. This is a nice straight line. You can go that way or that way, obviously. And then put a few of those together, thusly. And then at the end of the maze, you'll have this this piece, and that is that shape, that sort of squarish shape you can detect one way or another to determine you've made it out of the maze. And the other thing is this small piece of foam cheese that I picked up. And apologies to the Niner fans, this is a Green Bay Packer cheesehead hat for kids, kid size, but it's the best thing I can find. So the idea is this will be here next to this exit tile as well. So the table's a little small. So basically the idea would be this is the end of the maze. We have this this sort of an arrangement, and the cheese would be over here at the end as well. So there's a couple of ways you can determine the exit. You can pick up this square black tape shape. You can ultrasonically sense that you've gotten to the cheese. And the other thought is you could have like a little bumper on the front, mechanical bumper to detect you've run into the cheese, whatever works. So that's how you know you've completed the maze. And then I said in my presentation it would be good to have some kind of victory dance. So if I can pull this off here correctly, my guy will do his little victory dance. I'm still having a little trouble getting to follow lines, but we'll see how it goes. So giving away a little trade secret here, I have a calibration routine on my sensors to pick up the white and then the black so that I can adapt to various lighting conditions and things like that. Let's see what happens. So far, so good. Anyway, so he doesn't turn and run off the table all of a sudden. Eventually he'll get to the cheese and he'll say, hey, there's the cheese, and he does his little dance, and there you go. Well, yeah. So that's the idea. Anyway, any questions on all that good stuff? Pretty straightforward, I suppose, huh? And we're going to do this next month. We'll be phase 1, and then every 2 months will be phase 2, after that, phase 3. So June, and then August, and then October meetings. Okay, great, thanks.
I should comment here that for some of us who've been around in the club for a while, we went off and spent a lot of money working on IEEE's micro mouse mazes. How many of you have seen the YouTube videos of IEEE micro mouse and how fast they are? It's pretty impressive. Anyhow, we as a club combined probably put about $2,000 into buying maze pieces and stuff. Bill Spangler here helped, make our board pieces, drill the holes. We had people identify a particular black paint that was really absorptive. We spent a lot of effort on it. We really never had anybody build a successful robot that did micro mouse maze. Okay, so I'm hopeful that this will be a lot more successful. The thing I like about it is the cost of getting started is you need to buy a modest number of floor tiles from Home Depot, and it won't break the bank. It will not be thousands of dollars like we spent. Okay, so right now all the remaining pieces of the IEEE micro mouse maze are living at one of our club members' places called Logic, and anytime RoboGames needs to run an IEEE maze, we bring them all out. So basically, we as a club bought the micro mouse maze pieces for RoboGames. So that's kind of how it all worked. Okay, so now I'm going to hand over to UpDroid.
Hi there. So my name is Karthik, and I'm one of the team members of UpDroid. Okay. So I'm one of the team members of UpDroid. This is Mike and Don, and we are a small startup in San Francisco. So before I actually go into the details of what I'm going to show you guys, I have a small video too for you guys to see. Apparently the sound is not working. So that's actually, I'll just narrate. That's actually our robot we got at the Up1 series. It's a
The F1 series is modular, so that once you invest in the platform, you can upgrade components as new ones become available. You can program the F1's behaviors with UpDroid Commander, a development environment that runs in a browser like Chrome or Safari. A familiar tab-based interface includes the essentials like the text editor, file explorer, and console, with more cool features on the way. The F1 series is great for teaching and learning robotics. We're developing autonomous behaviors like watering your plants every day. For the pioneers, experiment with new robotics or computer vision algorithms, or maybe artificial intelligence.
Okay, yeah, so that's the initial cut of our video that we have. So I'm here to actually talk about the UpDroid's Commander interface. That's basically an IDE for ROS. The way it works is you have ROS and UpDroid's Commander, we call it UpCom, running on the robot, and then you can access your robot through our interface from any browser. Currently, we are actually going to access all the ROS files and everything on a robot, which is actually running at our office from here. So this is actually over internet. This is basically this is how it looks like. So we have three different components of the UpCom. We have a file explorer, an editor, and a console. So there are a couple of things that you can do. You can actually use this to create your new workspace just by a tap of a button. And then you have a full terminal on the side. You can use it to create a new package, your regular terminal commands. And there are like Mike will be going through a couple of steps here. He'll be So this is a full command. You can use all the commands that you use in a regular terminal. All of them are, or you can use any of them. This is a full terminal on your browser. Yeah, just wait for him. Yeah. So to create a new file or a new folder, you can just directly drag and drop new file. You can even drag and drop a new folder. You can double click on it and change the name. This is all happening all on your robot right now. Make it So yes, this is just a quick demo that we are doing. We also have a sample script that you can directly load. If you drag and drop it, there are templates for publisher and subscriber. This is just a simple hello world subscriber that we have here. You can then you can also have you can save it directly from here.
And that's how you crash it.
Yeah, and that's how you crash it. So it's basically in alpha phase. It's actually crashed right now. but yeah, so we are actually testing a bunch of other things. And the main aim of this whole project is to give a really simple to use access to ROS on your robot anywhere. That you can actually run it on your local system, or you can run it from wherever you are. Just as a side note, that's actually our robot. We have a modular setup. Just to give you a little, we won't be moving it, but just to give you a little glimpse of why it is modular, we actually have different modules for sensors, actuators, and the base and basically the brain. You can literally take this off. This is the sensor module, and then plug it back in. Magnets realign themselves so that you don't lose any positional data. You can also take the actuator module off and then plug it back in. You can swap things around too. So I think that's about it. We hope to show you a couple of other things, but unfortunately the commander crashed. That's it. If you have any questions,
So on, like, for example, that head assembly with a couple of ultrasonics or whatever, what is the interface between that and the body?
So are you talking about these?
Electrical and software interface between the units and the CPU, which is deep in the middle.
Okay, so if you're talking about the sensor module has USB interface.
That's USB.
Yeah, the sensor module is USB and audio in and out interface. All the other actuators, they have a serial UART interface. We currently have just for redundancy. We also have I2C interface too, but that's just for redundancy. Most of the talking is done over serial UART.
How long does it take to set all of this up on the system?
It's actually we have a Ubuntu package on it so you can literally download the package, and if you're running Ubuntu and ROS, then apt-get, that's it.
Which ROS? Which version?
Ubuntu 14.04. 1404.
Indigo or
Indigo. Oh, Indigo, yeah.
How much does it cost? Typical.
Oh, sorry, it's shining in my face. This software, by the way, is free right now. You can actually run UpDroid Commander on any of your robots right now, which is running Ubuntu. We will be launching an alpha version, which will be around $1,500 to $2,000. And it'll be in 1 or 2 months from now. We'll be shipping them out. The actual version will be around the end of this year or maybe early next year. Someone else had a question? That's it? Yeah.
Have you done any user testing on ROS? Because a lot of us here are trying to learn ROS, and it's not
easy learning curve?
Yeah, so actually I was new to ROS 2 years ago. So this was basically like we wanted to have, like we saw how useful ROS is, but how difficult the learning curve is. So we wanted to make a really simple interface, but give you the flexibility of ROS. So this actually reduces everything that you, everything related to ROS into just putting Python nodes one at a time. So currently we are sticking to Python nodes. We are not including C++. But just because it's easy to learn, that's the first language that any person learns. So you can literally write one node and click and run it. We have like build button, clean buttons. You can, if you go to the control. Yeah. So just by clicking that, it builds the whole system. You have a list of all the nodes here. Currently, because of new workspace, there is no nodes, active nodes, and you can run it directly from this interface.
You're running a terminal in the browser?
Yes.
What sort of terminal is it? What capability does it have?
Yeah, actually,
it's a VT100 terminal.
Okay.
But it's a real terminal.
Actually, it has all the capabilities that a regular terminal has.
So it's giving you a window in which you can operate the Linux that's in the robot?
Yeah.
Yes.
Yeah.
Yes, actually you can access your whole robot with this terminal. You can see it has a whole tree. You can actually create a couple of consoles, a couple of editors just by clicking just as a regular tabbed interface, and you can have multiple access.
ROS topic list.
Yeah.
Let's see.
So is ROS running?
Let's see.
Then I see you got a navigator on the left-hand side.
Yeah.
Is that just a file navigator, or does that give you?
So this is actually your workspace navigator, and it actually gives you all the files and folders inside your workspace.
What about all the ROS nodes that you might want to incorporate in your design?
So the way we have designed it right now is when you start Commander on your robot, you can give a particular file path, and if you give your file path to the existing folder that you are working with, it will directly incorporate all the standards that ROS generally uses for having a folder layout. So it automatically incorporates, and this here is actually giving you the contents of the source folder, the file navigator. Yeah.
Are you looking for help with the software?
Well,
at least on the ROS side.
On the ROS side, yes, a little bit.
Yeah, our robot needs more work for autonomous capability because we're trying to link like the navigation stack with other packages.
Actually, our software guy was in talks with someone here who worked with the ROS Arduino bridge, or who made the ROS Arduino bridge. So he was in talks with it. We used it for our robot too.
And what's the license on the UpDroid?
For Commander, so we are calling this UpDroid's Commander. This is actually, you can directly download it from Ubuntu. It's free.
Right, but is it like a BSD license?
Yes.
Okay.
Anything else? Yeah, we would have loved to show the whole thing, but unfortunately it crashed. So yeah, still in work in progress.
We're used to demos.
Yeah, sure. You can ask questions.
Thank you very much. Very good. For those of you who don't know what ROS stands for, it stands for Robot Operating System, and it was developed by a place called Willow Garage. It's completely free and open source. And us in the more amateur robotics community are really getting pretty excited about it, even though it's a lot of work to get a robot up and running on it. Okay, now I saw that Camp finally came. Yeah. He's the other guy with a nice beard like me, yeah. Okay, Camp, I held off on both Maker Faire and Tabletop Challenge so that you could do the intro, okay?
Is that what that's called?
Oh,
Hello. Okay, we had a wonderful time at Maker Faire. There were 12 participants. We had 20-odd robots. Hey, Frank. What was the coolest robot there? I think it was InMove, in my opinion. InMove is a full-size, open-source humanoid robot. And Wes Theory, Wes, you out there? He's actually built the arm from it. He's also working on a Darwin op. What? Anybody else that went to Maker Faire, or even if you didn't, what was the coolest robot there? Come on, speak up. We don't have much time here. Was it Watson, right? But you thought it. Watson was funny because Watson is Dan Albert's full-size humanoid. It was kind of standing there next to the column, and I think you weren't getting much action until you added the balloon head. And then people started noticing it. It wasn't just another 3D printer. But, oh, and outside there was Megabot Mark II, which is a full-scale battle mech. This thing has caterpillar tracks. It rises up like 15 feet, and it's got 2 paintball cannons. And they were shooting it at the poor defenseless Pittsburgh art car. It was terrible. And the boys of Ubiquity, of course, were there with their Magni and Loki and Dr. Bot, Alan Fetterman here, continuously pitching the product. I tell you, it was like a Robot Depot there. Mark Johnston and his small Ross bots. We had a pretty good store there going with the Homebrew Club, huh?
Yeah, that was fun.
Yeah, yeah. What was your favorite robot?
Unfortunately, we were slumming it next to that.
It was Bill and Becky Sherman with their robots in the classroom, and the esteemed Stephen Nelson with Beer 2D2, always a popular robot.
I personally would, which I'm biased in this way, enjoyed Marco's Magellan entry was there.
Okay.
Wasn't around, but I respect that.
And
Steve had his too.
Mark Medallions, who's it? Maxwell was there. Maxwell was there.
And the little Miro robot, the little egg bot.
Miro, okay. Miro is face recognition, lighted robots. Romibo was there with Jared of Origami Robotics.
And Nick Donaldson too.
Nick Donaldson, king of the hexapods, you know, the guy with the monkey on his shoulder. He was there. He was right next to us. Glider is his latest hexapod. It actually rollerblades.
Oh
yeah.
Okay, on 6 legs. Let's make that clear.
It's a hexapod.
Yeah.
Hexapod.
Not on 2.
Yeah. Now outside there was a Burning Man 12-legged spider robot that the guy would ride around in. He had like a dome sphere. So we had a wonderful time. Maker Faire. They had over 100,000 people come through there. And oh, I know what I was going to say. Meccano, the guys that do Erector Set, they have a humanoid that's really something. Got 2 models, G15 and G15K, something or another. But one's like 2 feet tall, the other's 4 foot tall. It's a humanoid robot. These guys had, like Baxter had a learning mode, smart servo, so you could like move it in different positions and then it would repeat those positions. It has voice recognition and voice synthesis. It's a humanoid robot. It doesn't walk, but it drives around on wheels. That's kind of a, yeah, it's not quite right, but it's okay. Those will be out soon at like $200 and $400 respectively. So Steve Alexander, ladies and gentlemen. Okay, so Maker Faire was a lot of fun. Yes.
I have to mention some of the new boards coming out, the Qualcomm and the Edison, and those things that are going to be really revolutionary.
New boards coming out.
Yeah, so a lot of new boards, based on phone technology. So the Intel has the Edison, which is like, a full-size system the size of a postage stamp. It's truly amazing. There's a computer that's the size of an SD card, practically. And they're putting those on drones that can fit in the palm of your hand.
Game of drones. They're flying and fighting drones there. It's like last drone standing. So Maker Faire, it comes around again next year, so you know, this build. And speaking of which, we have our own event coming up next month, the 13th annual HBRC Challenge. 1-3. So this is a builders club, folks. We build robots here. We don't just come and talk about them. And so I'm going to be on the mailing list, touting and cajoling and making all kinds of noise about building stuff. So we provide our own entertainment next month. And then if you don't want to hear me go over my tired old robots over and over and over again, bring something. So you got 4 weeks. Moreover, you got like 5 months because you got the 4 weeks. That's phase 1. Traditionally, we've done our HBRC Challenge June, August, and October. So you've got phase 1, June. Bring your robot in some state of finished, okay? And then you enunciate what your phase 2 and 3 are, and you'll bring your robots back again in August and October, and we'll see how well you've done. This is not a competition. This is a challenge. It's a show and tell, okay? It's all about the show. So is it Rick? Rick Phillips? Rick, are you here? We've got a new challenge, the amazing...
yeah, that's Ralph. He presented that earlier.
Oh, Ralph.
Yeah.
Ralph, right.
Yeah,
You got that right. Okay, so this is a new one, and you're going to be doing the same thing this month, is kicking everybody's butt to be building, right? All right, good. Sounds good. So we're going to, bring something, build something, and we'll have to talk to Ryan about the potluck dinner. Hopefully we can eat here. I'm going to bring some tables. Regardless, traditionally we've had a potluck dinner. Extra karma points for robot-themed foods. So next month is the 13th annual HBRC Challenge. Build something. Thank you very much. Okay. Build a robot specifically.
Now, 2 of our members here are wearing light green shirts. Okay, that's Alan and Bill. And they are on Team Maxed Out. Woo! And Maxed Out is going into the box tomorrow, I believe, right? Going into the box. Okay, and you're going to ship it out to Worcester, Massachusetts. And the goal of that robot is to autonomously find objects, pick them up, and take them home. Okay, very challenging. I think this is the 4th run.
Yeah, and NASA's getting kind of upset. They said if it doesn't happen this time, probably ain't going to happen ever.
Ooh, that's
Now or never.
Now or never. Okay, very challenging.
The stake is driven into the ground. No
Okay. So that's why a lot of members of our club aren't here tonight, is because they're doing the last minute tuning. Okay.
And 1 or 2 are watching this basketball game too.
Oh.
Too. Raise your hand, David.
Yeah, I haven't done my show.
Oh, okay. Sorry. But I couldn't recognize you without the shirt on, But, okay. Okay, so now what we're going to do, any more robots to show and tell? Okay, we're a little short on robots tonight. We got to do better next time. Next time will be the challenge meeting. We're going to take a 5-minute break, okay? Allow our speaker to set up, and in about 5 minutes we'll start the presentation. So 5 minutes.